This question is based on two subtopics. One is Kolb's electrolysis, another one is aromatization. So, first let us understand the question. Find the number of CH2 groups formed in the final product X of the following reaction. So, X is obtained from potassium salt of carboxylic acid after two stages. One is electrolysis, another one is molybdenum trioxide supported with alumina at a high temperature and pressure. Of course, this is used for aromatization, so we have to take the product only after aromatization. So in this, initially you are taking potassium salt of a carboxylic acid. Totally there are 4 carbon atoms. Therefore it is potassium butanoate. Potassium butanoate is IUPAC name. Potassium butyrate is a common name. And the first stage of the reaction is electrolysis. And during electrolysis, so in the aqueous solution, this carboxylate ion undergoes oxidation at anode, and due to oxidation at anode, this is converted to carboxylate free radical. Carboxylate free radical, and that is after oxidation, so that is a plus 1 electron. Of course, water will undergo reduction at cathode. As a result, you will get hydrogen gas. That is a different thing. And you are getting carboxylate free radical, and this is produced at anode. This is at anode. And this free radical, whatever the free radical produced, it undergoes various changes. The first change here, let me take this is your carboxylate free radical. Carboxylate free radical, and there is one odd electron. I'm writing only odd electron, and lone pairs I'm not writing. And one possibility, it undergoes a homolytic cleavage like this. Due to homolytic cleavage, that will give you n-propyl radical. That will give you n-propyl radical, and due to this homolytic cleavage, this carbon gets one odd electron. Oxygen already has odd electron. That will give you carbon dioxide gas. So there are many molecular species undergoing this change. So here this is the reaction of one species I have taken, and here the possible coupling reactions, if you take coupling reactions, in this coupling reactions, if you take, one is coupling of carboxylate radical, another one is coupling of a propyl radical. So don't think all molecules are undergoing this reaction simultaneously. There are so many possibilities. The first possibility is like this: coupling of carboxylate radical, coupling of carboxylate radical and n-propyl radical. As a result, you will be getting a product ester. So here that is n-propyl butanoate, n-propyl butanoate, and of course these are the 3 carbons. But this will not undergo aromatization in the second step. We cannot take this. And another possibility, coupling of these radicals, coupling of n-propyl radicals. Due to coupling of n-propyl radicals, you will get n-hexane. You will get n-hexane. So here you can see 1, 2, 3, 4, 5 and 6. You will get n-hexane, and this n-hexane undergoes aromatization in the second step. So this is used for aromatization. There are 6 carbon atoms, and if you see here, totally this is C6H14. During aromatization, that will give you benzene. So here that will give you benzene. Resonating structure I have written with the loss of course this is C6H6. Totally 4 moles of hydrogen is coming out, and of course that is the reason its degree of unsaturation is 4. So finally your product is benzene. The product is a benzene, and in this benzene there are no CH2 groups actually. Here he is asking number of CH2 groups. There are no methylene groups. All are CH groups only. There are no methylene groups. Therefore, your answer is 0. Your answer is 0. And of course, here I took only oxidation reaction, and there is another reaction, that is reduction at a cathode. So due to reduction, you will get a hydrogen gas and OH minus ions. Finally, these OH minus ions are present in the solution due to increase in OH minus ions concentration. So we can simply say, so here pH of the solution increases. So during Kolb's electrolysis, pH of the solution increases. But here I have not taken disproportionation reaction, because disproportionation will give you propene and propane. But according to the second reagent, we have to go for aromatization. So in that aromatization, only N-hexane will undergo aromatization, that will give you benzene. There are no CH2 groups, only CH groups. Therefore, your answer is 0 to the question. And degree of unsaturation of this benzene is 4. pH of the solution definitely increases during Kolb's electrolysis.